Everybody, happy Monday. So this is going to be our last week of Chem 1 review. We're going to review Chapter 9, which is Stoichiometry. This is where we left off last year. We're going to make it a little bit more complex in the coming days, and then we'll move on next week to new content, which is Chapter 9.2. As I keep saying, you definitely need to know and understand how to not only write equations from English and also how to correctly balance them. As of today's Friday, I'm making this video, looking and grading some of your 8.2 worksheets. Some of you are not understanding how to correctly write the equations, and therefore you're not balancing them correctly. Remember, if you have any type of questions, if my video lectures are not enough, you can come to office hours and get help directly from me live. My worry is that some of you are not actually watching the lecture videos, and therefore that's where your confusion comes from. So just be aware that I know virtual learning is not ideal, but this is our only option right now, and these lecture videos are the best I can give you given the circumstances, but I am available for live Zooms every day for those that need help or have questions, or some people are just getting on and doing their work with their camera and microphone off, but that way they can unmute when they have a question. I can directly answer them and show them on my screen how to work out the problem. So like I said, this is our last chunk of review. So chapter 9 part 1 was stoichiometry. So just to briefly review that, remember that stoichiometry deals with relative quantities of reactants and products. In chapter 9, part 2, which is coming, you're going to learn why stoichiometry is so important, specifically to the chemistry manufacturing world, the making of goods and products that involves chemistry. So recall there are 4 conversions, and these conversions are like going from one unit of measurement to another. For example, going from quarters to dollars, dollars to pennies. They're the same amount, just in a different unit. So I shouldn't say they're the same amount. They're quantities that can be converted between different units. So we have mole to mole, mole to mass, where mass is measured in grams, mass to mole, and mass to mass. Mass to mass is definitely going to be the one we use most often in Chem 2, but I want to review all 4 of these. And remember, they get more complex and there's more steps as you move down. So the very first things you have to understand before you can actually move on to stoichiometry problems are, number 1, how to calculate molar mass. Remember, molar mass is the sum of all the masses of all the atoms of all the elements in a compound. If we were just calculating molar mass, it would be grams per moles. However, when you plop it into a stoichiometry problem, you only need to write G grams because the mole is represented elsewhere. Okay, so just so you're practicing, you need your periodic table. You do not need to look at your radical sheet right now. You have to look at every element separately and show your work for this, because it's helpful for me to actually be able to see your numbers and potentially catch where you went wrong. So the first thing I do is I count, or I figure out what elements I have. I have aluminum, sulfur, and oxygen. The second thing I do is figure out how many atoms of each do I have. That comes from your subscripts. I have 2 aluminum. The 3 is outside the parentheses, so I have to distribute it, multiplication. So I have 3 sulfur, and then once again, distribute it, 3 times 4, 12 oxygen. So that comes just from the problem on the screen. Now you have to consult your periodic table, the periodic table side, not the radical sheet. You have to find the atomic mass of each of these. I round usually to a whole number, so your answer may be slightly different than mine if you're not rounding or just rounding differently, but that's okay. So on the periodic table, aluminum's atomic mass is 26.981. You can use that number. You can round. I'm going to use 27. And that's why it's not a huge deal if your number is slightly different than mine, because it just depends on the periodic table you're looking at and how you're rounding. On the periodic table, sulfur is 32.064. I'm just going to round that to 32. And oxygen is 15.999. I always just go 16. Okay, then I'm gonna grab my calculator. I'm gonna figure out what each of these equals when I multiply them. I got 54 for the total mass of all aluminums in this compound. 96 for all the sulfurs, and 192 for all the oxygens. And then you add those all up because it's the molar mass, it's the sum of all the masses of all the elements, and our final answer is 342 grams per moles. Like I said, that mole is going to kind of be elsewhere eventually. Okay, so hopefully you remember that. Just make sure you're distributing properly the subscripts, make sure that you are looking at the right element, and then make sure you are rounding correctly if you're rounding. I know some of you have been saying that it's kind of challenging for you to find the elements on the periodic table. It will get easier because you'll be looking at it so often, especially in these next coming chapters. All right, the second thing you have to understand for stoichiometry is mole ratios. A ratio is a comparison. So mole ratio comes from the coefficients of a balanced chemical equation. That is why I kept saying it's so important that you understand chapter 8 entirely, because if you're not balancing correctly, then your mole ratio is going to be off, therefore your stoichiometry answer will be off. That's also why I've been stressing the importance of chapter 7.2, because if you don't write the equation correctly, you're not going to balance it correctly, therefore your mole ratio will be off, and it just snowballs out of control, and now you get a wrong answer for stoichiometry. Okay, so first thing you have to do is balance an equation. So I'm just going to quickly balance this. Feel free to pause it and balance it yourself. I already have to erase because I wasn't actually paying attention to the problem. Hopefully you already beat me and you're already done. There we go. 416, let me check. Yep. Okay, so what's the mole ratio of PBr3 to P4? Well, you use the coefficients from your balanced equation. So it's 4, and the 2 dots means ratio to 1. Now we don't write it like that in our stoichiometry, but that's what it would be. Mole ratio of P4 to Br2, P4 versus Br2, it's 1 to 6. Okay, so you have to have the correct balancing first or you won't get the right mole ratio, but before that, you have to actually write the equation correctly. So watch your rules. I would say the biggest thing people are forgetting as far as in chapter 8.2, if an element is by itself, you don't have to put anything. So if you have like aluminum plus oxygen, aluminum's charge is +3, but that doesn't matter because it's by itself. So it's just aluminum. Oxygen has a 2, but that's because it's diatomic. So you guys just need to make sure you're remembering and watching those rules. That's where some of you are going wrong. Okay, so using mole ratio as a conversion factor, mole ratio is always the unknown substances coefficient from a balanced equation over the known substances coefficient from a balanced equation. I like to remember UK, unknown over known. The unknown substance will have a question mark under it in the stoichiometry problem. The known will have a number given to you. Okay, so our first conversion is mole to mole. Mole to mole is just one step. You have a given number of substance in the chemical equation. So you'll have that in moles. We'll say 2 moles of whatever. All you have to do is multiply by the mole ratio, the unknown's coefficient over the known's coefficient. The known substance in moles cancels out the known substance in moles. You're left with the unknown substance in moles, and that's what you're trying to find. So, first example. Let me balance it. 151. Remember, you can pause and do this on your own. Okay, so you have to balance it first. Now I can cite the stoichiometry. So my known substance is the one that has a number under it. So it's 2.4. You always need a unit, which is either moles or grams in this case, and you always need the label. The label is what substance are we talking about. So in this case, O2. That came from right here. 2.4 moles of O2 times the mole ratio, which is my unknown coefficient, 1 mole, mole ratio, the unit's mole, of what? P4O10 over my known coefficient. Once again, mole ratio is moles and my known substance. Okay, whatever you have out front here, moles of O2 should cancel out the bottom, moles of O2. You're being asked to find question mark how many moles of P4O10, and my unit's going to be in moles of P4O10. Okay, so 2.4 technically times 1 divided by 5. You always do times the top divided by the bottom. And you should get 0.48. Unit is moles of P4O10, and that's right here. And it's also right there. Okay, and I like 2 decimal places. Don't round like crazy. Okay, so that's mole ratio. It's also very important that you use all of these labels and units. So if you don't write moles of O2, moles of O2, moles of P4O10, moles of P4O10, you're going to lose a ton of points. I had a student a couple years ago take a Chem 2 test, and they had every single mathematical portion right, but they forgot every single unit and mole. So this is half a point, half a point, half point, half point, half point, half point. That's 1, 2, 3 points taken off just because of units and labels. It was a 10-question test. She missed 30 points. She failed the test because of that. Don't do that. All right, next up we have mole to mass. So we're going from moles of one substance to grams mass of another. 2 steps to this. So once again, you're going to start out with a known amount of substance in moles given to you in the problem. You're going from moles to mass. So the first step is mole ratio, unknown over known from your balanced equation coefficients. Then you have to multiply by the molar mass of the unknown. I'm going from moles to mass. I'm going to multiply by the molar mass of the unknown. The 1 mole of unknown is a constant. It just cancels out these units and labels. And then I have my answer in grams or mass of unknown. Try this one. Pause the screen. Try it yourself. You're going to need your periodic table. Molar mass comes from the periodic table. All right. Whoops. 2. Okay. 1, 1, 2. Now I can start the problem. Here is my known 4.5 moles of silicon chloride times my mole ratio, my unknown coefficient, over my known coefficient. I already know I'm good because moles of this cancels out moles of this. The next step is to multiply by the molar mass of my unknown, which is Cl2, 2 atoms of chlorine, the question marks under it. So 2 atoms of chlorine. I consult my periodic table. The atomic mass of chlorine is 35.453. So I'm going to round to 35. You don't have to. Okay, that's going to go up here. And then this constant down here is 1 mole of Cl2 because moles of chlorine cancels out moles of chlorine. Okay, so 35 times 2 is 70. That is our molar mass of our unknown. It's in grams. Okay, that's what I'm saying. Don't write grams over moles right here. Look, grams over moles. It's already written for you. Okay, so now you put in your calculator, multiply by the top, divide by the bottom, and continue. 4.5 times 2, technically divided by 1, times 70. Once again, technically divided by 1. And I get 630 grams of chlorine, Cl2, and that's what I was finding. Okay? Moles are usually going to be small numbers, potentially decimal, under 0. Grams are usually bigger numbers. Not always, but usually. Okay, so that's moles to mass. Moles of one substance to mass in grams of another. Oops, I forgot to write up here. 2 chlorine times 35, that is my molar mass. Okay, but when I put it in right here, grams over moles is already written. So I'm just putting a G on top of here. If not, say you put this, mole cancels mole, mole cancels mole, there's nothing left, so you would have to put grams over moles, which is not the unit of stoichiometry. All right, next up we have mass to moles, going from mass in grams to moles of substance. 2 steps. So now we're going to start with a known amount in grams. We're going to multiply by 1 over the molar mass. So 1 mole of whatever the substance is a constant, divided by the molar mass, just in G for mass. Once again, it's kind of weirdly portrayed, but it's still molar mass. Use your periodic table, and then you multiply by the mole ratio. So mass to moles, the mole ratio comes second. Still unknown over known from the balance equation. All right, so balance this one. This should be an easy one. You keep doing this one over and over again. It's pretty common. Okay, here's my known, 71 grams of H2. I have my unit and my label, times, it's mass to mole, so my mass is going to go down here. 1 mole of my known is on top. My known is H2, so I have 2 hydrogen, times the atomic mass of 1.008 or 1.01, on around 1, is 2. Once again, technically the molar mass is grams over moles, but I don't want to write grams over moles down here. I'm just going to write grams, because technically my moles is up here. I know it sounds weird, but I promise it's okay. Okay, so there's my mass. So grams of H2 cancels out grams of H2. And now I have my mole ratio, because I'm going 2 moles. Unknown over known. Here's my unknown coefficient. And here's my known coefficient. Oops. Make sure you have your units and labels right. And if you cross out, it actually does help you. Okay, grams of hydrogen cancel out grams of hydrogen. Moles of hydrogen has to cancel out moles of hydrogen. I am left with moles of oxygen, and that's what I'm finding, moles of oxygen. Okay, so in your calculator, 71 times 1 divided by 2 times 1 divided by 2. I get 17.75, and I'm going to leave it because I like 2 decimals. If you round it to 17.8, I would accept it. Don't round up to 18. Don't go crazy. Okay, moles of oxygen. Not a super, super small number, but it's small compared to 71 grams. All right, and last but not least, it's our most complex equation, mass of one substance to mass of another substance. Requires 3 steps. You're going from mass to moles, and then moles to mass of another substance. So 3 steps. The first is to divide by the molar mass of the known. Then you will multiply by the mole ratio, and then you will multiply by the molar mass of the unknown. So it looks like this. So you have a known substance amount in grams from the problem. 1 mole of unknown is a constant. The molar mass in grams of the known goes on the bottom using your periodic table, times the mole ratio, still unknown over known, comes from a balanced equation, times the molar mass in grams of the unknown, and then the bottom is a constant, 1 mole of unknown. 3 steps. Okay, so try this one. Pause it if you need to, balance it. So I'm starting with my known, 12 grams of NH3. Watch that you have ammonia and not ammonium. Ammonia is NH4. NH3, ammonium is NH4. Make sure you're reading your radical sheet carefully. Okay, I'm going to divide by the molar mass of my known. 1 mole of my known goes on top, it's constant. I'm going to find the molar mass of the unknown. So I've got 1N and 3 H's. N is about 14.007. I'm gonna round to 14. H is about 1.0080. I'm gonna round to 1. Add those together. The molar mass of NH3 is 17. Okay, mole ratio is next, unknown coefficient over known. There's my unknown coefficient. There's a question mark under it. Here's my known coefficient. And right now, we don't care about that. Okay, once you balance it, we don't care. All right, last thing is to multiply by the molar mass of my known. My known is H2, so I have 2 hydrogen. Once again, it's about 1.008. I'm just gonna go 1, gives me 2. So 2 grams of H2 goes on top. 1 mole of H2, 1 is a constant. Grams over moles, that's my molar mass. Now check and make sure. Grams of NH3 cancels out grams of NH3. Moles of NH3 cancels out moles of NH3. Moles of H2 cancels out moles of H2. The only units I'm left with are grams of hydrogen, and that is what I'm solving for. Okay, so in your calculator, multiply by the top, divide by the bottom. You don't have to push equals, you can just carry it through. So in my calculator, I'm typing 12 times 1 divided by 17 times 3 divided by 2 times 2 divided by 1. I just type it straight through. And I got 2.1176, blah, blah, blah. So I'm going to go 2.12 grams of H2. If you got 2.11, okay, you didn't round correctly, but okay. If you got 2.1, if you got 2.13, close enough. Should be very close. Okay, so hopefully that helps you, that reminds you of stoichiometry. By the way, my example numbers were a little bit off. Like I have example 3, but this is the only one for math. I apologize for that. So real quick, just to show you, okay? I like to show people. That whole thing is the step from mass to mass. Okay, we just did it. Take your known number out front, do this math, you get your unknown number in grams. That's mass to mass. Just that middle part highlighted in green is mole to mole. Mole to mole step, mole ratio, followed by multiplying by the molar mass, that's mole to mass. Mole ratio comes first, and then you multiply by the mass. And then the pink steps, dividing by the mole ratio, dividing by the molar mass of the known, and then multiplying by the mole ratio, that's mass to mole. Okay, so if you can just remember this, the middle step is just mole to mole. The second and third step are mole to mass. The first and second step are mass to mole. The entire thing is mass to mass. When you look at it that way, it's not a lot to remember. And mass to mass is going to be your best friend coming up. Okay, so hopefully that helped you. Tomorrow, there is a chapter 9.1 worksheet based on these problems. Make sure you know how to do them. And then we'll do another video, a little more complicated, on 9.1 on Wednesday, and then you'll have an assignment.